Hello and welcome to another one of these ADD videos. Today we're going to be looking at logarithmic differentiation. And basic rule for that is when you have the ln of some box, whatever the box may be, you're going to get a derivative of that box over the box untouched with no ln. Drop the ln. Okay? If the term looks like this, it's an log term instead of an ln term. What you do is you look at specifically this a, and you do 1 over ln of that a, and then you just use that same rule we were using up there, big arrow. Okay, and if you remember, ln of e is 1, so that's why it cancels out. Now, use your algebra rules to simplify your calculus. Here's some algebraic logarithm rules that might help you out. Okay, so if you remember that ln of a plus ln of b equals the product of those two terms, but when it's minus, it's division. And this one allows you to bring something down in front and get that b as a coefficient. That one's really helpful. It allows you to eliminate using the chain rule. And then here are some other ones that you might need to be remembered. As long as these arguments are the same, the answer will be whatever this exponent is. Same concept here. As long as these two, when it's in the exponent, are the same, it'll be whatever the argument of that is. Okay, and then this is the change of base one. This is a quick just algebra review again. Since our calculators only have base 10 but nothing there, right? Or ln, which is logarithm based e, right? You can change an unknown logarithm into one of those, so you can use your calculator if you need a precise answer. Okay, so that is going to help you out for your logs. So what do I mean by algebra? Well, let's look at this derivative. If you did the d box over box, the derivative of this box right here requires a chain rule. It would be the derivative of the outside, and you multiply by the derivative of the inside. Whereas if you just use your log rule, this rule right here, and bring down your exponent as a coefficient, you now have eliminated the chain rule. You can just do the derivative of that's -4 over that whole thing, and you're done. Don't forget that too as well. Okay. You can also use it in the sense of, let's say you have a nasty derivative. I'm going to get a different color besides yellow. Let's say you have y. Well, what's going on here? Can we get some different colors, please? Let's say you have a derivative that looks something like this. Well, what you can do is you can ln both sides, and when you ln both sides, you now have opened up a whole gambit, a whole toolbox of wonderful things that you can do to this and expand it out. So you could make the whole right side just be ln of the sum of the ones multiplied, and you would subtract the one that's divided. And then you wouldn't be done there, because then you could take those exponents and make them coefficients. And then your derivative becomes so much easier than doing, originally you would have to do a quotient rule, and within the quotient rule you would have had to do a product rule. Whereas here you're just using the basic log derivatives. Now, what does differ here is that because we are, I'll finish writing this before I go down that road. Because we ln'd both sides, this derivative now becomes an implicit derivative. So it would be 1 over y, but then we'd have to multiply by dy dx, and then we'd have to multiply the y over, plug back in what it equals in terms of x. And I'll show you an example video of one of those as well. But just to recap, the basic rule is d box over box, and if it's an log, you have a ln a that comes into play. Use your algebraic logarithm rules. I suggest just making some quick note cards and practicing. Okay? Hope that's cleared up the confusion on how to take logarithm derivatives. Make sure you check out the example videos. I'll do 2. I'll do some basic ones and then some slightly more complex ones. I hope this has clarified things. Practice, practice, practice. Thank you and have a nice day.